Most images of the universe show the same thing: galaxies, stars, light everywhere. That is a lie. Not intentionally, but false nonetheless. The universe consists mostly of nothing, of true absolute void. According to estimates, visible matter, everything we could ever see or touch, makes up less than 5% of the universe. The rest is dark matter and dark energy, things we know exist because otherwise the physics wouldn't add up. No one has ever seen them. And even this 5% of visible matter is not distributed evenly. It clumps together along the edges of vast, empty bubbles. What we see when we look at the night sky, those points of light, those structures, is the exception, not the rule. How vast are these distances, and how deep are these voids, really? Not in terms of numbers meant merely to sound impressive, but in a way that gives true understanding. Let's start small, relatively small. The solar system. Most people realize it is big, but almost everyone underestimates just how big. On average, Pluto is about 6 billion kilometers away from the Sun. Light takes a good 8 minutes to travel from the Sun to Earth. To Pluto, over 5 hours. New Horizons, the fastest probe ever launched, took 9 years to reach Pluto. 9 years to reach a destination that still lies within our own solar system. And when it finally arrived, it had a mere 30 minutes to gather its most interesting data before flying onward. And Pluto isn't even the boundary. The Oort cloud, the outermost shell of the solar system, extends, according to current estimates, up to a full light year away. We have never observed it directly. We infer its existence from the orbits of comets that occasionally drift into the inner solar system. Where they come from, the intervals at which they move, these are models, not measurements. Voyager 1, the most distant human-made probe ever, left Earth in 1977. Today, it is approximately 23 billion kilometers away. To fully traverse the Oort cloud, it would take another 30,000 years or so at its current speed. Of what lies out there, we have literally explored nothing. From here on, we leave behind what we know. Proxima Centauri is the closest star to the Sun, 4.2 light-years away. But what does that really mean? A light-year is the distance that light travels in 1 year, about 9.5 trillion kilometers, and Proxima is 4.2 of them away. With New Horizons, the journey would take about 70,000 years. The Roman Empire existed 2,000 years ago. We would not arrive with anything we have today. An interesting fact about Proxima Centauri, it is part of a triple star system. Alpha Centauri A and B orbit each other, and Proxima is bound to this system at a great distance. There is even a planet orbiting Proxima, Proxima b, which is located in the habitable zone. Liquid water would theoretically be possible, but Proxima is a red dwarf. It regularly emits strong radiation flares that would likely sterilize any planet in its vicinity. Whether life could ever arise there is questionable. When you know how far away the nearest star is, you can roughly imagine what comes next. The Milky Way has about 200 to 400 billion stars. That sounds dense. It isn't. The average distance between two stars in our neighborhood is several light years. What this means for collisions, even if two galaxies collide, and that will happen, Andromeda will collide with the Milky Way in about 4 billion years. The probability of two stars colliding directly is astronomically low. Galaxy collisions are essentially the flowing together of emptiness. The Milky Way also has a structure that one does not intuitively imagine. It is not a uniform disk. There is a central bar, spiral arms, a bulge in the middle, a halo of older stars surrounding the entire galaxy. In the center sits a supermassive black hole, Sagittarius A, with a mass of about 4 million suns. We sit at the edge of a spiral arm, not in the center, not at the absolute edge, somewhere in the middle of nowhere, within a galaxy that itself consists mostly of nothing. The Milky Way is about 100,000 light-years in diameter. Some newer estimates even say up to 200,000. We sit about 26,000 light-years away from the center. To cross the galaxy once, at the speed of light, would take 100,000 years. The fastest thing physically possible, according to everything we know about reality. It is, however, a bit more complex than that, because there is also something like time dilation, for example. But that is not the focus for the video today. Furthermore, there's another point that many are not properly aware of. The speed of light is not a technical hurdle that we will overcome at some point. It is a physical limit. The closer you get to it, the more energy you need. To bring an object with mass to the speed of light would require an infinite amount of energy. Andromeda is our nearest large neighboring galaxy, 2.5 million light-years away. When you look at the sky with the naked eye and search for Andromeda, you can see it under good conditions. You are looking 2.5 million years into the past. The light you see now left Andromeda when our ancestors were not yet using tools. Andromeda is gravitationally bound to the Milky Way, part of the so-called local group. About 50 galaxies within a radius of about 10 million light-years. Beyond that, emptiness. The next comparable galaxy cluster, Virgo, is about 65 million light-years away. The space between galaxies is another category entirely. In the Milky Way, there are at least stars, rare but present. In intergalactic space, there is practically nothing, perhaps one atom per cubic meter. No magnetic field leading anywhere, no dust clouds, no gas clouds. Simply vacuum, as complete as you can hardly imagine. Even light traveling through space there hits nothing. It simply travels onward. When you zoom out far enough, the universe no longer looks random. Galaxies are not evenly distributed. They hang together in clusters, the clusters in superclusters, and the superclusters are part of giant filaments. Thread-like structures, millions of light-years long, that stretch through the universe like a network of threads. Our galaxy belongs to a supercluster called Laniakea, only defined in 2014, when we analyzed the motion of thousands of galaxies and found that they are all flowing toward the same point, the so-called Great Attractor. Laniakea is about 520 million light-years across and contains around 100,000 galaxies. From a bird's-eye view, the universe looks like a foam structure, filaments and nodes where many galaxy clusters converge. And in between, voids. Between the filaments lie the voids, cosmic empty spaces. The Booter's void is one of the most famous examples, discovered in 1981, about 330 million light-years in diameter. Inside, a few dozen galaxies, where thousands would be expected based on average density. When it was discovered, hardly anyone could explain how such a void could have formed. Voids form because matter is pulled out of certain regions by gravity and accumulates in the filaments. The void expands over time. Voids are not completely empty. There are isolated galaxies inside them, so-called void galaxies. They develop differently than galaxies in denser regions. Fewer neighbors means fewer collisions, less gas replenishment, a different speed of development. Loneliness changes galaxies too. The Bootes void is large, but not the largest known structure. The Hercules Corona Borealis Great Wall is a filament estimated to be 10 billion light-years long, so large that some doubt whether it is truly a coherent structure. On these scales, the universe should actually look uniform. The fact that it doesn't is not yet fully explained. Light takes time. Most people know that. But the consequence is stranger than it sounds at first. The most distant galaxies observed by the James Webb Space Telescope, some over 13 billion light-years away, show us the universe when it was less than 1 billion years old. The universe is about 13.8 billion years old. If we look far enough, we see galaxies that formed shortly after the Big Bang. Galaxies that probably look completely different today, or no longer exist. We never see the universe as it is. We only ever see how it was. This has another consequence, the cosmic microwave background. If you look so far that the light has been traveling for over 13.8 billion years, you no longer see galaxies. You see radiation from the time when the universe was still so hot and dense that light could not move freely. That is the limit of what we can observe. Behind it lies not darkness. Behind it lies a physical wall from the past. The universe is expanding, not into something. Space itself is expanding. The further apart 2 points are, the faster they move away from each other. Galaxies are moving away from us faster than light travels. This does not violate physics because the galaxies are not moving through space. The space itself between us and them is growing. Light sent from there today will never reach us. These galaxies are forever beyond our sphere of influence. Over time, the expansion accelerates, driven by dark energy. This means the event horizon moves closer. Galaxies that we can still see today will disappear. Not physically, but drift out of our observable universe. In a few trillion years, if you think that far ahead, all galaxies outside the local group will have disappeared behind the horizon. A civilization existing then would look into the sky and see what looks like an isolated universe. No other galaxies, no evidence that there was ever more. They would ask the same questions we ask today, and have no way of finding the answers. The universe is big, we know that. It is not big in the sense of many things. It is big in the sense of almost nothing over unimaginable distances. We sit on a planet orbiting a star that is one of billions in a galaxy that is one of trillions in the observable universe. And yet, or precisely because of that, the dominant characteristic of the cosmos is not abundance, but separation. The stars, the galaxies, the filaments, all real, all impressive. But it is the thin framework around a vast emptiness. What lies beyond our event horizon, we will never know. I hope you enjoyed the video, and we'll see us next time.